Hello everyone, our video is entailing how to determine the terminal velocity of a ball using differential equations.
Here from the diagram we have a ball and we have two forces acting on it, the weight force mg and the frictional air force minus kv. From this we can make a formula for the sum of the forces equals mg minus kv, where m equals mass, g equals gravity, v equals velocity and k equals friction force. We can now consider the displacement to equal s, the velocity to equal change in displacement over change in time to equal v, and acceleration to equal change in velocity over change in time to equal a. We can now make the formula F equals mg equals ma. Here mg equals ma as g is equal to a as gravity is equal to acceleration, which equals 9.81 meters per second. We can now perform a differential to get m equals m dv on dt. We now let F equal m dv on dt and substitute. This gives us a first order linear differential equation.
Okay, so our example is a 1 kilogram steel ball is dropped from an altitude of 1 kilometer. As it falls, air resistance is equal to v on 4, where v is velocity, and this air resistance is described in proportion of velocity. We're going to determine the terminal velocity, which is the ball's maximum velocity. Firstly, we'll define our values. So g equals 9.8 meters per second, k equals a quarter of v, w equals mg, and m equals 9.8. So using our equation, m dv dt plus kv equals mg, dividing out by mass gives us dv dt plus k on mv equals g. Now we'll substitute in the values we defined before, giving us a dv dt plus 1 quarter on 9.8 v equals 9.8 meters per second. Now I have the equation in the correct form to use the integrating factor method. So I'll simplify a quarter on 9.8 to give 9.8 on 4 and plug this into Rx. So Rx equals e to the 9 on 4 to t, and e therefore equals 9.8t on 4. And we'll multiply this, which is the integrating factor, throughout the equation to give below.
We're now left with the left hand side, which is equal to the product of the Rx function. Here, d on dt, e to the 9.8 on 4tv equals e to the 9.84t multiplied by 9.8. Integrating both sides cancels the left hand side to be left with e to the 9.8t on v on 4 multiplied by v equals 4e to the 9.8 on 4t on 9.8 multiplied by 9.8 plus c. Performing a u substitution, we're left with 4 du over 9.8 equals dt. Substituting values and simplifying, we can now rearrange to make v the subject of the equation. Dividing by e to the 9.8 on 4t yields v equals 4 plus c e to the minus 9.8 on 4t. Now we can apply boundary conditions to find c. Here t equals 0 and v equals 0. The substitution process leaves us with c is equal to minus 4.
This gives us Vt equals 4 minus 4e to the negative 9.8 on 4t. Alright, now we're finding the maximum velocity of the ball, so to do so we're going to take the limit as t approaches infinity to give us the V max, which is velocity max. So the limit as t approaches infinity of Vt equals the limit as t approaches infinity of 4 minus 4e to the negative 9.8 on 4t, and therefore after substituting and finding this limit, the terminal velocity is 4 meters per second. Alright, so this is the end. Thank you for watching our video.